Hello and welcome to the last video of 5.3, the pH scale video clips. In this lecture video, we'll be looking at last 4 boxes here. Firstly, CO2 dissolves in rainwater to form carbonic acid, which is a weak acid, giving rainwater a pH of about 5.6, which is quite natural. We will then look at equations for the reaction of CO2 with water to produce hydrogen ions or hydronium ions to prove that it's going to be acidic. Secondly, oxides of sulfur and nitrogen in the atmosphere can produce rainwater with a pH below 5.6, which is acid rain. We're going to then write equations for reactions of oxides of sulfur and nitrogen with water that lead to acid rain. Finally, we'll give you a point of discussion to examine the human activity that can cause acid rain to form and the strategies used to prevent this from happening. Okay. Now, acid rain. Now, there is carbon cycle in the nature, and it is normal for carbon dioxide to be present because a lot of natural things even emit carbon dioxide. The carbon dioxide can dissolve into water and can make water acidic, and which is quite normal. The rainwater is naturally acidic, which is about 5.6 of pH. Natural causes include erupting volcanoes, respiration of animals or even plants in the nighttime, and also decomposition of organic matter, which usually makes carbon dioxide if there is enough oxygen there. If it's an anaerobic condition, it makes methane gas. Artificial causes, which could be burning fossil fuels or growing feedstock. If you are growing so much of feedstock, say cows for meat purpose, they would be producing a lot of carbon dioxide as well. Now, this diagram shows the storage and also fluxes of the carbon dioxide in gigaton per year. So, something that I wanted to point out. Respiration that normally happens would be 60 gigaton per year, and soil respiration is also 60. Photosynthesis that consumes carbon dioxide is 121.3 in this diagram. Volcano, which you can't find it here, but I found this number from somewhere else. It's at 0.7 gigaton per year, so it's not so much compared to even the respiration of something that's natural. Whereas fossil emissions is something that you can find here. This fossil emission, 7 gigaton per year, is something that I found. It's a later number. 5.5 is a bit even less. 7 is what? 100 times more than volcano. Hang on, no, 10 times more than volcano. That's quite significant, isn't it? So humans' footprint is everywhere in terms of carbon dioxide, and something that nature can absorb again. When carbon dioxide dissolves into water, so whether it's an acid or soda water that you can produce at home, it makes weak acid, carbonic acid, H2CO3 that is. This is an equation, so write it down, memorize it. pH would be about 5.6. It's not in the lower range of acidic range of pH scale, so yeah, you can say that it's a weak acid as well. Because it's a weak acid, when it's present in water, it only partially ionizes. Therefore, you should use two-way arrows. So some carbonic acid is dissolving and some are going back to carbonic acid molecule instead of staying as ions. But in this second equation, you can see that carbonic acid can cause the increase in concentration of hydronium ion, which causes the acidity. Make sure you memorize these equations. Now, carbon dioxide is not the only thing that contributes only a certain bit, because it's just a weak acid as well. Acid rain is defined as rainwater with pH less than 5.6. So here it is. 5.6 is quite important number too. So make sure you know that. More acidic than neutral rain, that is. Natural rain. Keep saying neutral. Natural rain. Human activities that can cause rain to have pH which is less than 5.6. Excessive emission of CO2, as we established, it can create carbonic acid within raindrop. Oxides of sulfur, which could cause sulfurous acid and sulfuric acid. Make sure you know the formula and strength as well. Oxide of nitrogen, which also causes nitrous acid and nitric acid in air, in the water drop. Again, if you don't know the name, formula, and their strength, make sure you know them. Now, sulfur is found as contaminant in many fossil fuels. Say our body contains a lot of phosphorus as well, part of it. So even if you burn it, it's not going to be just pure carbon that you would be able to use for burning and getting energy out of. Oil, petrol, coal, they are not just carbon. They will always have some sort of some certain amount of sulfur, phosphorus, and other stuff. When those fossil fuels burnt, what can happen is sulfur combining with oxygen. Then you get sulfur dioxide gas. It's a non-metal and combining with oxide. That is a non-metal oxide. Do you remember the nature? It's acidic. Yeah, so if that touches water, then you would get acidic solution. Sulfur is also found as an impurity in metallic ores. So if you want to produce zinc, for example, zinc sulfide for the production of zinc. That should be in yellow because you should remember the two though. So zinc sulfide plus oxygen. If you burn it, that's a roasting process it's called, to get rid of sulfur. Zinc will be bonded to oxygen, so zinc oxide will happen, which is what you want to further purify later on. You also get the byproduct, which is SO2, again sulfur dioxide. Now, sulfur dioxide, that dissolves into water and then forms sulfurous acid, H2SO3, which is a weak acid. Some sulfur dioxide, before touching the water, it can react with oxygen to become sulfur trioxide, SO3, which is still gas. Sulfur trioxide then dissolves into water. What do you think that you will get? You will this time get H2SO4, the sulfuric acid, which is strong. The precipitates, which is in a meteorological sense, it's a rain. It's something that precipitates and come down. Yeah. So yeah, they are the acid that would be contributing to the acidity of rain. Make sure you memorize these equations as well. Now you've got a few more equations to memorize. In this case, it's the oxides of nitrogen. Oxides of nitrogen also contributes to the formation of acid rain. Nitric oxide, NO, is one gas. Nitrogen dioxide is another gas. Make sure that you don't confuse that with nitrous oxide. That one is the one that makes you laugh or makes the muscle go up when you're having a dental operation or whatever, or make cars go faster. That's a nitro booster that you might have heard of. Hammond from Top Gear made this car that has got the same gas that works for laughing gas as well as nitro booster, so it goes faster. Triple covalent bonds, which exist in nitrogen. So nitrogen has got always 2 atoms. Triple bond is very stable. It requires a lot of energy to break, therefore it's very stable. High pressure and high temperature is needed for you to break the bond between nitrogen atoms. So whenever you have that sort of environment, nitric oxide or nitrogen dioxide can occur. So natural causes like lightning or bushfire. Artificial causes could be internal combustion engines. Surprise, surprise, it's cars. Furnaces for you to get metals out of some sort of ore, and other industrial process. This reaction can occur. N2 plus O2 becomes 2NO. So colorless gas can come out. Then this can further reacts with oxygen to produce NO2 gas. Now, NO2 gas can react with water, and it can make nitrous acid, which is HNO2, and nitric acid, HNO3. Nitrous acid is weak acid, and nitric acid is strong acid. Because the nitrous acid is a weak base, you could also represent that in this in this equation that's written below. So you can see that nitric acid can be separated, but not nitrous acid. They both contribute to acid rain because, well, they're both acid. That's that. Now, make sure you memorize these equations in yellow as well. Now, for human to, reduce the impact of acid rain, things like catalytic converter, chemical scrubber, desulfurization processes, carbon washing to get rid of all the sulfur before burning, new low emission car engines have been also invented as well. These things have been invented for this particular purpose.